Tonight's speaker is also from College of DuPage. Paul Sirvatka is a professor of meteorology. So tonight, obviously, we're going to be talking about weather in Illinois, especially some severe weather. And any questions you have, please put them in the Q&A. So I'm going to hand it over to Paul Sirvatka. Thank you so much for being here tonight, Paul.
Well, thank you for having me come and talk. I always like to talk about the weather, even though I do nothing about it. So we'll see if anybody knows what that quote is from. But I do want to kind of talk a little bit about the what kind of weather is affecting the Chicago and Illinois and all that other stuff. And we can answer any questions you have about weather. We've had some pretty exciting weather a couple of weeks ago, and finally we've just come out of a flash drought, and we're getting some pretty decent rains the last couple of days. So it's kind of nice to have a cloudy, boring day. Little bit of thunder last night helped me sleep really well. So let me tell you a little bit about College of DuPage Meteorology. We are the most comprehensive community college program in the nation when it comes to two-year schools. I started this a little over 30 years ago and have built it into pretty much an internationally known group. We have a number of courses. Now, a lot of colleges have maybe an introduction to meteorology, but we started with that. We built a severe and unusual weather course. We do several semesters of forecasting. We do a more advanced high mathematical intermediate meteorology, which now transfers to NIU as a junior level credit. We do have severe weather analysis and mesoscale meteorology, which is talking about small event weather. We have a thunderstorm lab, that's what we call it, but it's typically known as storm chasing, so we go tornado chasing. We do have a course that we developed in climate and global change, and then hazardous weather and preparedness. And we have home of NEXLAB. Now that's the name of our website. We'll talk a little bit about that. We're also known for our storm chase program, as we were the first institution in the world to actually offer college credit for storm chasing. And now there's dozens and dozens of colleges that do the same thing, many of them built upon what we did here at COD. So we have one of the most commonly used professional websites in the nation, in the Northern Hemisphere. When we look at Canadian meteorological programs, anything in the United States, they're going to go to COD. In fact, I've had many, many stories where the very first thing they do is talk about what's going on at COD. We have these type of users at COD. Oh, this is not scrolling like it should, but we do have a number. Some of them, we have Cornell University, so we're looking at some Ivy League. We have the US Navy as a big user of what we do. We have users from emergency management schools, government agencies, military, local newspapers, broadcast media, and they use our website quite a bit. Now, this is not like weather.com. So there are things that the typical person might come and see, local radar, local forecasts, but this is usually, we have a lot of image generation. Just to give you an idea, recently we have about 38,000 unique visitors every day. We have over 10 million hits, and we're putting down almost a terabyte of data, or I'm sorry, almost a tenth of a terabyte of data, over almost 900 gigs of data. When we have a hurricane, we even go higher than that. So when people start using our website, they're using it for satellite, they're using it for radar, they're using it for numerical models. And we take a look at some of these high-level events. And so next couple of slides are going to show you some of the billion-dollar weather, it's called weather and climate disasters. So back in 2015, we've got wildfires out west, which is raging again this year. Funny thing is, we had a big drought this entire year, which led to some of the fire weather. This last couple of years, the fires have actually come about because of a lot of rainfall. So we have some severe weather, things you would expect. We have flooding, which is a major disaster, which we'll talk about. Go to 2016, the drought was still going on, didn't have that much fires, burns out all the vegetation, so fire is not a big risk. We have a number of hailstorms, flooding, maybe some of these are the early spring floods. We had a big fire event in Tennessee and the Appalachian Mountains, a couple of severe weather, and Hurricane Matthew hit back in 2016. 2017, we have the same concept. Again, fires out west. We start getting up into Dakotas, getting to drought, hailstorms, and now we have a little bit more hurricanes. We had gone many years without a lot of hurricanes, or significant ones hitting the U.S., and this year had three big ones. Harvey, which was one of the record flooding hurricanes, Hurricane Irma, and then Hurricane Maria, which hit Puerto Rico. Come 2018, we do have the same kind of things. Now we have some snowstorms. So we have some billion-dollar snowstorms that wreak havoc on the Northeast. Again, fires out west. Are you getting the pattern that fires in California are just not uncommon? And this is kind of interesting. When we go to 2019, we have the same thing, and we'll look at the same thing going on this year. It's a little bit more widespread this year because we've gotten back into some dryness. But back here, we had just a ton of rain in the early spring, and that rain leads to vegetation. And then when it dries out like we expect it to, that vegetation is the fuel for these forest and brush fires. So it was a pretty bad year. This was a number of tornadoes back then, 2019. We had a tropical storm produce a lot of rain, and then Dorian hit up the East Coast. So every year we face several events that are billion-dollar weather disasters. Okay, so we're going to talk about some of the weather that affects Illinois more specifically, and then talk about things that you could do for safety. This is a tornado climatology. I love this map. We're averaging around 1,200 tornadoes a year. This is over some 50-year period, and if you kind of envision all these regions, the brighter the colors, the stronger the tornadoes. And we look around and say, gosh, there's no place east of the Rocky Mountains that looks like it's safe from tornadoes, and that's correct. You get tornadoes all the way up through and into Canada quite a bit. We get tornadoes throughout the entire Midwest. We normally think of this as Tornado Alley in the Midwest, but we actually have a number of tornadoes that come through Iowa, Indiana, Illinois, into Wisconsin and Michigan. We also have a big area of severe weather that hits in the south early in the season. And this is what we call Dixie Alley. And then we have some darker areas. And really, most of this is probably because there's mostly forest and there's not that many people spotting the tornadoes, but there may still be a number of tornadoes that go unreported. We go to the west, same thing. Lots of mountainous areas, but there's a number of tornadoes through the Valley of California, off the west coast in the desert southwest. There's really no place in the continental U.S. that's free from tornadoes. And I say continental U.S., I'm really also thinking about Alaska and Hawaii, which do get tornadoes as well. If I look at the frequency and I say, well, okay, of all the tornadoes, which are the tornadoes that, where's the area? And if you'll see that of all tornadoes, the most common region would be centered over about Oklahoma. That's really the tornado capital of not just the United States, but the world. And it goes down into Texas, maybe up through Kansas and in Nebraska. This is your prime area, but central Illinois, look at that. It's a pretty nice little spot. But when I start shifting to deadly tornadoes, the ones that are acting as killers, this is shifting a little bit further to the east and across the south. And there's a reason for that. Looking at the mobile homes, when we say mobile homes, we're not talking about trailers per se, but prefab houses that sit upon cement slabs. And these are extremely vulnerable to tornadoes. But there's another reason than just mobile home population, which is very high within the southern states. And that is that there's significant tornadoes, meaning the really strong ones. There is a high emphasis that when we get these tornadoes in February, March, and April down in portions of Arkansas through to Alabama, these are going to be significantly strong tornadoes. So that starts resulting in deaths outside of the mobile homes. There's even permanent structures and vehicles. Those are your three big areas where people are getting killed. So it really shifts the emphasis into the south. And this basically says, this is the area that we're most vulnerable. We are most vulnerable in the southern United States. Out west, there's less trees. You can see tornadoes coming. People are prepared for these tornadoes because there's a high frequency of all of them. And there's a pretty good warning system. Over here, the tornadoes hit at night. lots of forest. Mississippi is a very forested area, very difficult to see more than a few blocks away. And so tornadoes can come upon people with very little visual evidence that they're going to hit. Here's the 2020 tornado season so far, along with some other tornado seasons from the past several years. And we are seeing right now, we're only at about 960, what we call inflation-adjusted tornado trends. So this is a fairly close number. We're actually fairly low this year. It's actually been a very slow season. May and June, which is what we normally think of as tornado season, was really slow in the United States. So 2020 may have been a horrible year, but in terms of tornadoes, it was not very many. By this time, we could have had a year that would get us over 1,400 tornadoes. This is the lowest amount that we have over several years. Well, we're going to take a look at deaths on record. Very interesting statistically, right? So we're looking at somewhere around 70 to 90 people on average die a year. Now, in 2011, we jumped up to 553, and there was a number of big tornadoes, including the Joplin, Missouri tornado, which killed several hundred people. And so those big events, those ones that have an urban footprint, those are the ones that are going to skew the statistics. And as we enlarge in our urban footprint across the central United States, we will see tornado deaths probably returning a little bit more, not because there's more tornadoes, but because there's just more people in the path of these tornadoes. However, coming after 553, a high year over the last several decades, we had 2018 only suffered 10 fatalities. Currently, and I've got to move this a little bit. I'm going to move this over here. 2020 death count is only 78. So that's actually a fairly high year for a year that hasn't had that many tornadoes. There was a couple of early season tornadoes in March, some in Tennessee that caused double-digit fatalities. So that's where most of that is skewed to. Courtney, if you want to interrupt me anytime with any of the questions, I will let you say if you find a question that's pertinent, or we can answer the rest at the end, or whenever they seem to fit in there. So
sure, we do have a question actually.
Okay.
What is the inflation-adjusted tornado count?
What typically happens in their scenario is we do these raw tornado counts, and those reports tend to get inflated. So I don't think this has anything to do with monetary policy. What we're basically saying is when we look at how many tornadoes there are, we might have said, well, there's 5 people who reported a tornado. Those are the raw tornado reports, but people will go back later on in the year and say, well, that was really 2 tornadoes that was reported several times. And so the actual number comes down. So we're trying to adjust for a little bit of an overcount. So that's a good question. Now, let's focus in on Illinois and look at the tornado climatology of Illinois. And we are seeing what appears to be a larger number of tornadoes coming in recent decades, where we can start saying, well, gosh, is this global warming leading to more tornadoes? As we're seeing a number of years with 120 to 140 tornadoes. Now, there was a year back here, 1974. I don't have any pictures of my audience. So if anybody was around in 74, that was known as the super outbreak, which had 300 and some people died. In a 24-hour period, there were 148 tornadoes. So that was a really high death. Xenia, Ohio was one of the more famous tornadoes. Allstate used to do commercials about Xenia, Ohio. But there was a number of tornadoes in Illinois that year that created a high death count. But here's what I want you to see, is if we look at tornadoes, now we rank tornadoes based upon how strong they are. Here it says F, which stands for Fujita scale. It's named after a University of Chicago professor who sort of perfected the idea of tornado climatology. His name was Ted Fujita. And since then, we have the enhanced Fujita scale. We have a little bit more science going into how much damage this can happen. Now, tornadoes are governed not by what they look like, not by what radar is saying, but what kind of a damage path do they do. So we go from an EF0 to EF5. Now the Plainfield, Illinois, which we just celebrated the 30th anniversary of that, is an EF5 tornado, very, very strong, violent tornadoes. And there's not many of those a year, maybe 2 or 3 on average in a year, maybe none at all. To the EF0 or EF1, which are what we call weak tornadoes. And if you look at the strong tornadoes, we start seeing that there's really not much of a trend. If any trend in Illinois, the trend is downward to fewer of the violent tornadoes. What we're seeing is an upward skewing of the amount of tornadoes, and the reason for that is more and more reports of tornadoes, especially as we go into the late 90s, where Twister came out and there's more and more storm chasers out there. So they're reporting weak tornadoes that would never have been entered into the database back in the 50s and 60s and even the 70s. So as a climatologist, you would not look at the entire tornado count to try to figure out if there a change. We'd look at the strong and violent tornado count to get an idea of the trend. And we're seeing a pretty much a flat line or maybe even a slight decrease. And that's in Illinois, and that's also true nationwide. It is still nation's most furious wind. So I can look at tornado days. And again, this is saying how many days in the United States do we get tornado reports? And we see a slight declination in that line from 1990 to the current day, to the 2000 teens. I'm not sure if this is statistically significant, but there is definitely a little bit, and there is some evidence that there may be fewer days, more outbreaks of tornadoes, but they don't happen as frequently as they did in the past. Now, tornado destruction, whether or not it happens a little bit more or a little bit less than the past, when it happens is still devastating. And this is an example of what some of that devastation may look like, where you see trees that are denuded, you've got pieces of aluminum and siding that are wrapped within the trees, just utter destruction, people's lives completely destroyed within a matter of seconds. Here's one of the things I try to point out to people. School buses, vehicles, they're bad places to be during a tornado. Here's a bus that obviously rolled several times. It's coming off of its frame, badly hit by a tornado. These are not something that you want to see driving in severe weather. So if you know anyone in schools, you need to make sure that people stay in the school when there's an event. That's a much better place. Now, I want to show you this slide here. Oh, let me go back. I should be able to show this. This is a tornado in, I think it was Iowa. And it's just a security camera that somebody had of this event of a house across the street. Okay, so it's not a very long video, but we start to see that the tornado is actually drawing air in. And now we start to see the circulation creating a change in the wind. And this is how houses get destroyed in tornadoes. Even though we don't see much of the tornado, the roof starts flying off, and the next thing you know, the whole house collapses as we're into the vortex. So one of the things that I want to point out to you is a lot of people say, well, what do I do if I'm in a home during a tornado? Well, the first thing you do is you've got to get to the lowest level, most interior room. Now, there's sort of an old myth that says, well, you should open the windows to equalize the pressure. And that is just completely false. A tornado can open the windows for you. Basically, what you're saying is if you have a few seconds to seek shelter, you need to stay away from windows because of the flying glass. Open or close, it's not going to change anything. What happens is the air goes up and over the roof. It acts like an airplane wing, which creates a lower pressure because of the airflow over your house, and that's going to pull the roof off. And so when the roof fails, then the walls don't have any sort of support, and it's easier to knock down the interior walls. Now keep in mind that most tornadoes will not destroy a well-built house. There'll be inner rooms, like a bathroom, that will still be standing even with a strong tornado. A violent tornado, you look at some of the background of this. This is Greensburg, Kansas. These are houses that, you know, this would have offered some protection, but there's some houses like on the left where there's nothing left of the house. So if you don't have a basement, this house would have been a really bad place to be. Here is a tornado. This is actually Canada's strongest tornado. This was an EF5 in Elie, Manitoba. And I just want you to see a couple things on this video because it's pretty awesome. Now, I'm going to go back over here and I want you to look at this piece right over that comes up here. So let's watch it. That is, I don't want you to do that. I just want you to pause. That is, look at what it does. It just keeps doing that. That is I'll play it. That is an entire house going up, being drawn up by the tornado. And this is what makes a tornado even more destructive than a hurricane. Hurricanes are horizontal winds for many hours of time. They can do incredible amounts of damage. But a tornado's wind is not just horizontal, it's also vertical. It actually draws things into the air. So let me go back and let's see why this is not acting the way it should. So watch this house go. Now this next thing is a minivan full of drywall. So watch this thing over here, right there. Think of how far that tornado has lofted a minivan full of very heavy drywall. So that was maybe 60, 80 feet in the air. If you were in a vehicle that has that type of ability, the flight would be scary, but the landing would be fatal because that's where the problem lies. Okay, now here's another one that I want to show you. This is a little bit disturbing. This happened in Illinois, Fairdale, Illinois in 2015. And this guy named Clem Schultz, he was in the house up in his bedroom watching the storm. And his wife, who was downstairs, died during this tornado. It's an amazing thing. This is an EF4 tornado. So this is a violent tornado. It's a fairly large tornado, maybe about a half a mile wide in diameter. And we kind of joke about this. If we're watching a tornado and it's not moving from left to right, it's just getting larger, it means it's coming right at you. So I'm not sure why he didn't feel the need or the desire to seek shelter and just keep filming, but he's very quiet. You'll hear him breathe a little bit heavier. And then this is how fast the tornado strikes and does what it can do. So I'll just let you listen to the intensity of the video and how the sound starts to increase. It's gotten quite a bit wider and hasn't really moved at all, so it's coming right at him. So that is what it sounds like in the heart of a very violent tornado. It's an amazing thing. It lasted for, you know, a good number of seconds to a minute, maybe a minute and a half. He was knocked out in this, and he found the video was still okay at a later point. Like I said, he lost his neighbor and his wife in this thing, and he just took the video as everything fell down around him. It just gives you some idea of the power that a few seconds before it got incredibly loud and it kind of went dark, you could see all the material flying into the tornado. You know, you go back over here and you can see it flying into the tornado because the tornado is drawing air in. And then the winds become so apparent that now you're within the actual vortex itself and everything just flies off. There's very little that can stand, you know, winds that are exceeding 200 miles an hour. But you'll see the entire house be lifted up, all the power lines come down, just utter devastation, glass breaking all over the place. So that's an amazing video, and I'm thankful that Clem was able to share it with the community, and we got to see what that is, because those are the kind of videos that some people want to get, but it's extraordinarily dangerous. Okay, so now we're going to look just at the thunderstorms that spawn the tornadoes. And we see in Illinois that we're somewhere in the 40 to 50 tornadoes per year, days of thunderstorms. I think we've been really low this year. We haven't had that many thunderstorms. It's been kind of sad. I love storms. The mountains in Colorado generate thunderstorms all summer long. And then, of course, the primary thunderstorm state is Florida, which is ironic since its motto is the Sunshine State. They get over 100 days a year with thunderstorms. Now, a thunderstorm means it's a rain shower producing lightning and therefore thunderstorm. And it's lightning that obviously kills. So here's an example of maybe a 48-year history of lightning fatalities. And we see that Florida is your #1 fatality state. And that primarily is because it's got the most thunderstorms, plus people are outside and they get struck by lightning outside. Your house is usually a very safe place for lightning. Vehicle is a decent place, but outside is not a good place. And there's a lot of people doing outdoor sports, golf, and they suffer fatalities quite a bit. When we look at the amount of lightning, obviously across the central United States into the southeast is your most amount, and then along the Gulf Coast into Florida, there's your lightning capital of the United States. Not so much out west where the temperatures are cooler with the ocean. Now, flooding is another disaster. It actually is the most common type of natural disaster in the world. 40% of all natural disasters are coming from floods, and it is also the most deadly natural disaster. So it's the leading cause of weather-related deaths in the United States with over 200 deaths per year. It's amazing how dangerous water is. And I think the biggest problem is people don't realize how bad a situation driving into flooded highways can be, especially when that water is moving. I've seen examples where people die in 2 to 2.5 feet of water as their car flips over. So your car in 18 inches of water will float, and if it's moving, it'll push it off the highway and it can flip. And people just have no idea. So there's a motto the National Weather Service has. It says, turn around, don't drown. If we look at a 10-year period from 1988 to 1997, floods cost the United States an average of $3.7 billion per year. And just gives you some idea of the amount of flooding that can happen. 50% of flood-related drownings are related to vehicles. Turn around, don't drown. Now, when we have these type of heavy rains, flash floods usually occur very rapidly, like in a flash. However, long periods of rain will start to lead to river floods. And when rivers flood, that's where you do all the destruction. Now, river floods, because we know they're coming, don't cause deaths hardly ever. And usually it's a free example because we know the water is rising. Flash floods, people are unaware. River floods, we know. This was an event in 2013 of April, I hope you remember that far back, where This is part of Illinois that got between 4 to 8 inches of rain over the entire northern third. It was some of the worst flooding I've seen across northern Illinois. Sometimes we get these really heavy flash floods associated with thunderstorms, but then that's a localized area. Naperville, Illinois, back in the early 1990s, got, or mid-1990s, it was like 1995, got 19 inches of rain overnight. That's a huge thing. But that was pretty much Naperville. Up here in Glen Ellen and Wheaton, we didn't really have more than a few inches. But this was 4 to 8 inches everywhere, and there's just no place for the water to go. Lake Ellen had water overflowing into the streets from the lake itself. Really horrible stuff. And here's the Illinois River. It's hit a record height flood of a flood stage almost 30 feet above normal. Now, some thunderstorms produce hail. We've had some good hailstorms recently. We'll get a few here and there. And they cause a little over $1.3 billion of crop losses and another $1 billion of property losses. The hail capital is really in the plains. Northeast Colorado is your big area. Illinois, we have about 6 to 8 hail days a year where we get some decent hail. But usually we're looking at maybe inch and a half. That's not going to be that bad. You start getting up here to baseball size hail, to softball size hail, now we're talking about major damage. Here's an example of a baseball at 2 3/4 inches, and here is the hailstone that matches that of the baseball. So imagine this coming down. The updraft, the air in the thunderstorm going up is about 81 miles an hour to support that. Coming down, gravity's acting with it, you're looking at baseballs coming down at you over 110 miles an hour. So it could definitely kill people. And it has, hailstorms have killed people. Not that much, but they have had events of that. Then we get these windstorms. And this is a little island, it's called a packwash storm up north, where all the trees get blown down. And we know them as derechos. And I think all of you who were here a couple of weeks ago should be very familiar with these storms called derechos. Little background on what that word means. Back in the late 1800s, a lot of people were moving west, and there was a lot of stories about Iowa and a lot of tornadoes. And so people didn't want to go out there because they were afraid of tornadoes. And some scientists went out there and says, you know, the damage is not really that of a tornado. It's from a line of wind blowing everything in one direction. Well, tornado comes from a Spanish word that means to twist, to turn or to twist. Al derecho means straight ahead. So this, instead of being a turning storm, is straight ahead. That's why it's called a derecho. And these things can be really big storms, really damaging winds. We had a very famous one in June of 2012 that started out here in the western suburbs. Started in Wheaton, Glen Ellen, Lombard, Villa Park, Elmhurst. When it ended, it had gone 450 miles in 6 hours. It had an average speed of the line itself was 75 miles an hour. And it thousands and hundreds of thousands to millions of people were without power as it went into the Atlantic. I don't know if many of you recall this storm. You know, if you were here sitting in a room, you'd probably be nodding or you'd say something. Commonwealth Edison actually won an award for quick service, amazing service after this derecho, even though there were people in Wheaton that were out of power for about a week. Very similar to what we had last time. And the reason is they can't know this in advance. This derecho we had a few weeks ago was we hardly knew there were going to be strong damaging winds till about 24 hours in advance. And then we don't know exactly where it's going to be. And when it finally hit, now it's all emergency response. The crews from Michigan and Wisconsin aren't being sent here to help. So it takes a while to get all those crews to take down all the live power lines, to take down the tree branches, etc. Now, there was a really famous event a couple of years ago in Missouri with a line of storms, another derecho, and there was a duck boat, one of these little boats that go out as tour boats, and it capsized. I think there were some 17 people who died in this event, and you can see this line here on radar. The captain was, not a meteorologist. So there were warnings going on, but the captain says, well, I can beat this red stuff. Because to a lot of people, the red stuff is where the storm's bad. But notice that the rain and the really bad stuff is about, 15 to 20 miles away from this little white line. This white line is where the winds were bad. So not knowing that, or maybe seeing something like this with a different radar perspective, would have missed that this was the event that you had to look out for. So when you hear a warning from the National Weather Service, you need to heed that warning. Don't go looking at your phone thinking you know how to interpret radar, because most people don't. When we look at winds, you notice Illinois is a pretty good area. The derechos come across the Midwest, where we're looking at 10 to 15 days of wind damage every year. A little bit more out in the south, where we get some bigger storms, especially as we go into the early season, February and March. Just to give you an idea, this is in the Midwest. This is out of Jackson, Kentucky. Notice that tornadoes maximize April, May, and June, but winds are going to be more May, June, July, and August. So we get the wind event as more of a summer event. So when we have these derechos around here, July, early August, late June, that's when we usually have our big wind events. If I just generally think about windy days, this is interesting. Our windiest month on average is April. July and August are our two less windiest days, months of the year. And we start to see winds picking up in September and October, and I think you've noticed that we've had a lot more wind the last couple of days. As we go into November, it'll maximize again, and then of course the cold wind chill is horrible. And that leads us into winter hazards. So here is the snowfall record from 1884 to 2012 of days where we've had at least 1/10 of an inch of snowfall. Notice that we have a few days in the middle of October. So really we're looking at maybe another 3-4 weeks where we can be pretty well clear of getting snow. I say this while early September, they're getting a foot of snow in the Denver area. But once we get into November, we have a lot of days where there's going to be more snow. And we really get into near Thanksgiving, all the way through into April, we have a number of snow days. So notice it starts up slower with some days of snowing in November, but we have quite a number of days in through end of March and April, and that just makes spring seem to be forever and coming. Winter lasts forever in March and April around here. This was, of course, the Snowmageddon storm, the big snow blizzard that we had, the Groundhog's Day blizzard of 2011. This is Lakeshore Drive, which is not a good place to be. Other hazards we have are ice storms. This is an example of an ice storm pulling down trees, just amazingly devastating in terms of the damage to trees and power lines. And here's where your biggest threats for ice storms are. And Illinois is getting a little bit more in terms of ice storms, but really central Illinois and the deep south is where you get your big ice storms. Now, here's something interesting. Let's look at temperature trends from 1900 all the way to around 2015, sometime around there. We notice that there is this blue trend which shows us that the average temperature has increased slightly over the last 110 years. But we're only talking about a degree per century. That's a very small trend in Illinois, in the Midwest. So there's our average temperature. And we notice that the average is swamped by the fluctuations from warm to cold. So we get a big year, 2013, with very warm, and we're followed by a very cold year. So when it goes up, usually comes back down, and that's what we'd expect. Now, when we look at precipitation, the green is the annual precipitation. And so if we look at it, we're like, well, looks like we're going up a little bit. Interesting thing, this is winter precipitation. Notice in the last 120 years, we do not see any change in the precipitation during the winter. Okay, so 120 years in Illinois are showing no trend. So when do we see the uptick? We see it in summer precipitation. Now, this is ironic. That would be an indication of climate change. But do you know why this climate change is taking place? This has nothing to do with carbon dioxide in the atmosphere. This has to do with our corn and our soybeans in Illinois. We have better abilities to grow more and more density of crops per acre. More bushels we're able to grow per acre. And as a result, we are putting a huge amount of water vapor into the air, which is leading to an increased rainfall amount. So that's kind of an interesting trend. We don't see it in winter, but we see it in the summer, and that's because of how we deal with crops. So when people talk about climate change, I want you to remember that it's not just CO2 that we should be concerned with. It's how do we use land. We modify our environment. Other things that you may hear about are El Nino. Now, El Nino is a warming in the Pacific equatorial waters. So in the Pacific Ocean, especially off of South America, we have an area that the waters, if they're warm, that's called an El Nino. El Nino is actually a word that meant the Christ child. And they said, well, sometimes the waters are colder than normal. So they said, well, let's call it an anti-El Nino. That was the first suggestion. And somebody says, well, wait a second. If El Nino is the Christ child, I don't think we should call something the Antichrist child. So instead, they call it La Nina. So they changed that over. And it gives you some idea of when there's a strong El Nino, or a moderate or a weak El Nino, what does our average temperature do? And during an El Nino, we tend to see warmer than normal winters. Not always, but more often than not. But when it's moderate or a weak El Nino, is it going to be warmer or colder than normal? And the answer is yes, probably one of the two. So El Nino, we're tough to do this. Now, we talked a little bit about drought. This is the current drought in the United States. Now, we just came within the last 2 years of an all-time record low amount of drought in the US. It was the least amount of dryness that we've ever experienced in the United States. So this is fairly current. This is really reflecting last week. And in the Midwest, the only place of really extreme drought is parts of Iowa. So they had that windstorm, didn't produce that much rain, very dry. We can see that on satellite. Recently, they're getting a ton of rain. So really, when we look at the new drought indications for next week, we're going to see a bunch of this area start to go away. And really, we're only into a moderate drought in Illinois, and that will go away. This rain this week will probably be enough to what we call ameliorate the drought, make it less. In the West, it's a little more droughty than normal, with some exceptional drought down in Southwest Texas. So this is where it's been very dry. Up in Oregon, which is where the fires are really bad, is pretty bad. California, Southern California is really not bad at all. It's a little bit drier, but California tends to get their rain every few years, and then several years where they're fairly dry. So we'll watch this and see how that progresses. This is just fire weather season. If you want to know your weather outlook for the next 2 weeks, here's the 8 to 14-day probability of hot weather out west and much cooler weather across the central United States. So we're going to be a little bit below normal. Obviously, we should be in the mid-70s now. And we're only getting, I think it's 60 degrees here. South Florida's warm. Precipitation is going to be dry over most of the country. So after we get this rain this week, it'll go back to being dry with maybe rain across the south. If you're ever interested in storm chasing, then I would recommend that you visit this link. We didn't get to chase in COVID year, which because there were so few storms out there, it's actually, if we're going to miss a year, this was the year to miss. But we're going to try to get back out there again next year, and we do take students, people from anywhere in the country, anywhere in the world can storm chase with the College of DuPage. And we actually have a number of people from many different continents coming with us. And that's my talk on weather. So that should give us a pretty good amount of time to answer questions, because I know that tons of people like to have questions answered on the weather. So
that was fascinating. I hope lots of you go storm chasing with COD. I didn't know it was open to everyone. That's awesome.
Yeah, everyone can do it. It's a self-contained class.
Very cool. So yeah, if anyone has any questions, feel free to throw them in the Q&A function down below. We had a comment about the derecho in 2012 that they lived in
Oh,
Virginia,
right.
and
Yeah,
they
that came
remember.
through, it came through overnight, I believe, right? If you were there.
They said
Um,
they remembered it very well. Yeah,
yeah,
feel
so that,
free to.
I had some friends in Arlington, and they said they came over in the evening hours. It's like, whoa, what's going on? Let's talk about safely chasing tornadoes. Well, we have a lot of experience, so we know what we're doing. We use a lot of radar information to make sure that we're plotting it. I mean, we get close, but we know what's going on, not just with technology, but also visually what's going on. So safety is our number one concern. So we don't try to do stuff that you see maybe on TV with those vehicles. We're not doing that. We're trying to stay on the south side of the storm to watch it as it crosses our path. And they are more predictable than most people believe. So somebody was talking about the derecho versus a standard tornado. Well, a derecho is going to be associated with the line of storms. Okay, so the line tends to bow out. That's why you see these arcs in the radar, I guess. I don't know which way you'd see it moving this way. And at the leading edge is where the winds are very strong. Now, in a derecho, there are times where you get what we call spin-ups, little vortices, little areas of rotation, which is what tends to create a little bit more enhanced damage. Now, this is not going to be the kind of tornado with the big funnel that everybody's going to go, oh, look, there's a tornado coming. You're not going to see a funnel most likely in a derecho in a line event. We find out that there's tornadoes. We look at radar. We look at areas where there's rotation. And then for the Wheaton one, I went out there and surveyed the damage for the Weather Service. And I was able to ascertain, based on some evidences of the damage, that there had been a tornado from Wheaton College right there at the College Church, just a little bit through the college, and then a much longer path of enhanced damage and a little bit stronger damage was in Lombard in the Villa Park over by one of the parks over there, just a little bit east of Lilacia Park. And that one looked like it had tornado damage. And there was some really significant damage there. So both those tornadoes were governed as EF1, but these are not the typical, what we call supercell tornadoes, the big storms that are isolated where they can produce the EF4 and EF5 tornadoes. So those are the ones that I usually chase, not the line. The lines are just coming too fast. Oh, okay, so you have one of the, works for the Western Regional Climate Data Center. Oh, that's awesome.
Yeah, it looks like that was that person's son that
Yeah,
did
that's
that.
awesome. Chris, have you written to me before? Email, I think. I don't know if you were talking about that or if you had talked to me about this for the Chicago AMS, American Meteorological Society, but we'd love to have them give it a talk. If you want to just email me, I think it was on there, Sirvatka at cod.edu, Sirvatka. You got my name down here in the picture, I think, so feel free to do that. That's really cool. That's one of the ways that we monitor droughts. There's other ways of looking at droughts. There's fire weather. I really need to show you something that I think you might be interested in. So let me go over here for a second and show you something from our website, because this is happening currently. So this is not necessarily my meant to be in the talk. Let me go over here and steal the window into this one. This is our satellite and radar page, and I'm going to go out to the west. Well, let me go regional. And we have a product where you can actually, it's called Natural Color Fire, but we can color things red where there's hot spots. So looking at Oregon and Northern California, it gives you an idea of where the fires are. This is using satellite to see those fires. And notice that the winds are from the east, blowing the smoke out into the Pacific. So this big cold air producing snow and very cold conditions across the west is creating an easterly wind that's blowing this smoke into the Pacific Ocean. But man, I just think that's really cool that you can see that kind of fire. If I go to a localized sector over here, It's pretty impressive. And we can even see them overnight from last night. We can go back plenty of time. So you can see them burning at night. And a lot of forest fires forest firefighters want to know these things. So during the day, you can see the smoke plumes, but even at night, you can see what they're hot spots. Now, we're not seeing red like a fire. We just color them red based on the images that we can create. But we do see the heat coming from these fires. They're huge. These are huge forest fires across Oregon. And there's thousands of people using this imagery to help understand what's going on there. So let's talk about the tornado season. Would you make any correlation due to COVID for the lower trend? No. People would have still spotted it, especially out west. There were still chasers. There just weren't any storms out there in May and June. It was a very dry storm season. And we usually identify tornadic storms and significant ones, significant tornadoes by radar. Also, does Lake Michigan serve as a weather break? Yeah, you know, not necessarily. It doesn't stop weather. We can get tornadoes that actually go into the lake. Sometimes it can create cool air and keep the environment not favorable for tornadoes. The lake has huge amounts of snow and rain impact, temperature impact. So Lake Michigan is such a large lake, it totally affects the weather on a fairly large scale. But no, it doesn't really directly do that when it comes to tornadoes.
There's a follow-up question with Lake Michigan that just came in. Does Lake Michigan impact rain or snow in central DuPage County? Because many storms appear to be north of I-90 or south of 88. Is there any reason for this?
You know, here's the thing about storms, because there's not a person in the country who thinks storms ever hit them. They'll go, yeah, the storm was coming and it went north of me or it went south of me. And the reality is that's true. That is an event that happens to everybody, but it's like being at a toll booth. I'm going to pick a toll booth and I want to pick the shortest or the fastest line. It always seems like another line is going faster than I am. And the answer is, well, it is. If every booth has a 1/3 chance of being the fastest, that means you have 2 out of 3 chances that one of the other sides will be faster than you. So keep that in mind. Tornadoes or storms do the same thing. You think they're going north, you think they're going south, they still hit you. So we perceive it, it's not really accurate. Storms don't favor a certain area. As far as Lake Michigan is, if you get lake effect snows, now that's a different idea, because when the winds come over the lake, that's when they're actually enhancing the weather that creates snowfalls. Usually those are with, here, let me go over here to Lake Michigan. Usually we're talking about something that's going to be out of the northwest. You know what I'm going to do here? Let me do this. This is my epic pen. I can do this fun little pen thing I do for my classes. Hold on a second. I'll go to my ink and I'll go to this one. When the coldest air comes over the lake like this way, and actually I probably could have just done an arrow and made it straight a line, then that's going to pick up warmth and moisture, and my biggest areas of precipitation are going to form in areas somewhere across Indiana, maybe into Michigan. That's your snow belts. Gary, Indiana, and toward Buffalo. Really big events. If we're going to get anything out here, then the winds need to come off the lake in the opposite direction. And that happens on occasion with some of the bigger storms. And what that allows to happen is you can get some lake banding across Cook County into DuPage. Kane County is a little bit further west. They can get some remnants, but Cook and DuPage tend to get a band of snow that may be enhanced. But usually that band will start to shift a little bit more this direction as we go into Indiana, Michigan, and this area. So these are your biggest lake event, snow events. How does El Nino or La Nina impact polar vortices? Well, you know, a polar vortex always exists. We technically had a polar vortex this summer. when we had some really cool weather. It's just because it's summer, it's not going to be nearly as cold, but we had some incredibly strong vortex signatures of these things. Polar vortices always exist. It depends on how much they get dislodged from near the polar areas and then move further south, and they can bring with it some pretty sizably cold air. So anytime you have a really big cold outbreak, you're going to probably be associated with the polar vortex. The one we had a couple years ago was very significant, one that you may see only every 30 to 40 years. How wide can tornadoes get? The widest tornado that I've seen, I heard about, is about 2.3 miles wide. That's a big tornado. Most are going to be between a quarter to a half mile wide. Okay, let's see, what else do we have? Why does it seem we didn't get too many tornadoes in the middle of the night like some areas do? One of the things that happens is thunderstorms that produce tornadoes need instability. Okay, you probably heard the term unstable. Unstable weather is basically due to the sun heating the earth. So the sun will make it warmest. Thunderstorms will start around, let's say, 3 to 5 in the afternoon. That's when your thunderstorms start to really get going, or start even. But the winds become strongest around, 8 o'clock to 10 o'clock at night. So a lot of times you'll get those big isolated storms in the early evening hours. In the summertime, that's still light, so it's not really a nighttime. But there are times where the atmosphere is so dynamically driven with warm and moist air. And so what I would really want to do is something like this. I want to go over here to the deep south and think in this region, because you're close to the Gulf of Mexico, you're able to return really humid air to the north rapidly. And so even though you don't have sun at night, you're making the atmosphere unstable by warm, moist air coming off the Gulf. And that's why your areas in this part of the United States is really your violent tornadoes, because the winds are incredibly strong in the wintertime, February, March, late winter, and yet I can still bring really warm, moist air. You could have really cold, you could have really cold air up here and really warm air here, and then we have sort of a front that goes on in the middle someplace, and that's where the ground is favorable for storms. So I don't need the sun all the time, especially in what we call the dynamic cold season of February, March. But when we get to spring and summer, then we get more into the daytime hours. So there's some of the questions answered. If you have any more, feel free to send me an email. Let me.
Oh, we do have a couple more that were in the chat, if you don't mind.
Yeah, absolutely. Let me do this.
So,
Let me
oh yeah, can you see?
stop the share. Yeah.
So one question was, can the public sign up for COD storm alerts?
No, we don't do any of that right now, but I will show you a page that you can go to. I guess I gotta share the screen again, so I'm okay with that. Let's get rid of this guy. If you go to our main weather page, it's called weather.cod.edu, and it's always going to give you a weather satellite. We have a weather dish on our roof, so we can always see the current temperatures. Glen Ellen, Wheaton. There's a little radar, so we can see some storms off to the south, maybe more off to the northwest. Nothing in our immediate area. But over here, it says local weather. You're free to look at any of those things. We do have something called campus weather, and we try to have some indications of things that might be going on that you might be interested in, where we're looking at hazardous weather outlook. That's something that you can get used to every day. We will have watches and warnings. We are going to be creating a page, I think that's exciting, where we have this page, where it's hazards, and we can look at warnings. So freeze warnings all across the Midwest, winter storm warnings across Colorado, fire weather warnings out west. We're not getting too much, maybe a little beach advisory, small craft advisory. But you have access to this information. We're going to try to get this page in the next couple of months. You're welcome to use this, but we don't send out alerts. That's done by other private companies. So everything we do is free, and we just can't take on a mailing list at this time.
Well, that website is really cool. So,
Yeah, this is all new, and I think this will be really fun for emergency managers, because if you wanted to know what's going on, you click on it, and you can see heavy snow, additional snow accumulations, 4 to 18, etc.
Yeah, and I put that URL in the chat if you all want to take a look. And then the last question I have here was if you could elaborate, if you have any information on how crops affect moisture in the air.
Okay, so one of the things that's interesting is you have, if I had an acre of a lake, so imagine a lake that covers an acre. During the day, water is going to evaporate, and that water vapor gets in the air. It affects what we call the dew point temperature. Now, the dew point is a way that you can kind of feel it. When you're feeling like it's nice and it's moist out there, dew point's probably in the 50s. You get dew points in the 60s, you're going to say, oh, it's really kind of humid. You get dew points in the 70s, you're going to go, oh my gosh, this is sultry. This is really awful. It's so humid, I can't stand it. Doesn't matter what the temperature is. Relative humidity does, so I don't like relative humidity. But the dew point. So the dew point goes up as you evaporate water from a lake. Here's the thing. If I were to replace that lake with mature corn, an acre of mature corn, that corn, through transpiration, through the leaves and the stems, is going to put more water vapor in the air than the lake would put in the air. So when you multiply this by hundreds of millions of acres of corn and soybeans, you're putting in more water vapor than we did 50 years ago. So that's a local land use. So what we do is we have temperatures during the day that don't get as hot, because humid days don't get as hot. So we have a lot of temperatures in the 90s, but we don't get in the hundreds that often. But our nighttime temperatures don't tend to go as cool in the evening, so our overnight temperatures are warmer. Cooler in the day, warmer at night. Averages out to about the same. But those kind of conditions with more moisture lead to more thunderstorms. More thunderstorms lead to more rainfall. So that's how corn and crops affect climate.